Hey, hello there. My name is Professor Ramel. I've got a weird name, Tarmo, and I prefer that people refer to me by that name. And you might be thinking, how am I ever going to remember that? Well, I've got a nice little trick for you. Tar your driveway, mow your lawn. Put the two pieces together, tar, mow, and you've got my first name, and you're unlikely to forget it for a really long time. My goal today is to introduce you or ease you in just a little bit into our quantitative analysis course that you're going to have to take at some point during your program, most likely during your first term in the fall, starting in September. So let's talk a little bit about what's coming your way. But before we get into the guts, I'd like to take you on a quick little trip to this place called New Kiama. Quick show of hands, who's been here before? Probably looking around, I don't see any hands up, and I don't blame you. But it is a real place. New Kiama, California, United States. It's right there, that red dot on the map. If you can't see it, I'm going to put an arrow on there, point to it, get to know this place. If you're ever there, you're going to want to look for the sign that identifies this town. And it's not unlike anything you'd expect to see when you're driving around from town to town, whether it's in Canada or in the United States or elsewhere. There's often a large green sign with white lettering that tells you where you are, and usually the name of the town or the city or the village that you're entering is at the top of the sign, as it is right here. And there's nothing wrong with that. Many places will even list their population. New Kiama happens to have a thriving metropolis of 562 people. Probably one of the reasons why you haven't been there before. It's also in a mountainous region, and they love to tell you what their elevation is above sea level, and it's no different in New Kiama. They sit at a beautiful 2,150 feet above mean sea level. Again, nothing strange, and you're probably wondering, why are you showing us this right now? Hopefully it'll become clear in just a moment. But these signs have other information on them. This one happens to have the year of establishment of this town, 1951. And again, in that greater than half-century time period, they've amassed a whopping 562 people in this location. But what's really interesting is that this sign has a white line drawn on it and then the word total written at the bottom, and somebody has taken all of these numbers and added them together. And you're probably laughing and giggling and thinking, well, that's really stupid. Yes and no. I mean, this sign is a farce. It was designed as a tourist destination, a place where people would stop and take pictures at. But it highlights something really important that resonates with this course and other courses that you might be taking and your general life beyond these courses and your degree. And that is, taken out of context, if these labels weren't on the side and you just had those numbers on the right, you could add them up. If you were a computer, you could tell it, add these integers together, and you would get the total that's presented at the bottom. That in itself isn't a problem. The issue here is that when we provide these numbers with context, that is, we tell you that one of them is a date and one of them is a count of people and one of them is a measured elevation above sea level, we've now changed what you can do with these numbers. And the key message that this sign brings us is that just because you can do something, the simple act that you can take numbers and add them together and not get an error, doesn't necessarily mean that what you do is going to make sense. And I want you to keep that tucked in behind your ears, because we're going to come back to this idea in just a little bit after we look at sort of quantitative methods and quantitative analysis and statistics from a slightly broader perspective. And then we're going to come back to this idea of what it is and how it is that we measure things so that what we do with those numbers ultimately makes sense to us. So with that in the background, I want to ask you a question. What is it that you think of when you hear the word statistics or quantitative analysis or quantitative methods? Do you sort of think about graphs and charts and tables of numbers? Possibly, yes. We can see here on the right different types of graphs and different types of representation, things that you might be familiar with, things that you've seen but aren't quite so sure about. But we're going to talk about how we describe and visualize numeric data using these devices to draw meaning and trends and simplicity out of what's otherwise just large tables of numbers might be hard to take a look at. Which graph do we use? When? Why? How? These are things that we're going to cover in quantitative methods. You might be thinking, oh, this is just going to be an old crusty dude standing in front of a chalkboard and writing down formulas all day. No, that's not going to happen. Will there be numbers? Of course there'll be numbers. Will there be equations? Yes, there will be equations. Do you have to memorize all the equations? No, you don't have to memorize all the equations. You can look them up. But things happen much more easily and more quickly if you understand what it is that you're doing and which equation you need to use in what instance. My goal in these classes will be to get you to that point where you know exactly where to look and then follow a sequence of steps to answer the question. I think of this course more about problem solving using basic arithmetic, addition, subtraction, multiplication, division, more than a math class or a series of equations class. This really is about solving problems and giving you the tools to do that, things that you can then use in your other courses throughout your degree. You might be thinking, I haven't taken math for a long time, it's all Greek to me, but if you were to zoom in on the text on this page, you'd realize that's not Greek, that's actually Polish. Don't worry. We're not teaching this course in Polish either. It just happened to be a free diagram that I was allowed to use for the making of this video. But the idea is that we want to take that complexity and that sort of mathematic background and put it into a context that makes sense so that you can recognize what the problem is and then go to the right section of the textbook and follow the sequence or the process of steps to get at a meaningful answer to the question that you're asking. You might be thinking, whoa, statistics, probability. This is going to make me rich at the casino. While I don't condone going and gambling your life savings away, if you do learn a little bit about probability in this class, which you will, then understanding these games of chance likely going to make more sense to you, and you might decide that you don't actually want to go to the casino because the odds are against you. But we will look at and try to understand how some of these games of chance actually work. You might be interested in people and characteristics and traits and measurements and trying to figure out how do you group people or whether one group of people has a certain characteristic versus another group of people. These types of comparisons are at the core of what we do in quantitative methods and quantitative analysis types courses, where we try to figure out whether or not the average grade or the average height or the average something in one group is actually different from that in other groups, or whether one group is more variable than another group, and giving you tools that allow you to make those assessments based on a set methodology. So it's not I've got a gut feeling that this group is better than that group. Well, this allows you to produce methods that answer those questions that are repeated or repetitive so that anybody who does that analysis gets the same answer. You might be interested from an environmental perspective. We know that there's an area around a garbage dump and there's going to be leaching of contaminants into the soil. Well, what if I take measurements in those soils and then I take measurements in an area that isn't a garbage dump? Can I somehow quantitatively compare how similar or how different those measurements are? I'm going to show you how you can do that in this course as well. Not today, but those are the kinds of things that we approach in this introductory course. You might be interested in agriculture, and you want to know whether or not one field is more productive in terms of its biomass production than another field. Are you getting more corn out of this field or that field over there? Are you using more or less fertilizer, and what is the impact on what you're doing? Again, the methods that we teach in quantitative methods allows you to start to answer questions of this nature. If you're interested in grapes and grape juice and adult grape juice, you may have heard of the term terroir. and that is, how does the specific site where the grapes are being grown affect the flavor and the quality of the wine that is made at those locations? If you know something about the geology, the soils, the chemistry, the hydrology, the stress, the moisture, the temperature regimes, the grape varietals, can you decide what you expect to happen in different terroirs or different vineyards? Again, the tools that we cover in this class allow you to make those assessments based on fact and, again, not on gut feeling. You might be interested in the health of people taking supplements, and is one group being sort of outperformed by another group? There's a whole range of these types of comparisons that we're going to set up and teach you how to work through so that you can tackle these kinds of things in any of the courses that you're taking to give you the quantitative skills to answer the questions that you might be asking. You might be working on an assembly line and you're filling these cans with some sort of beverage, and you want to make sure that the cans all get the same amount of material, and you measure sort of the variability of how much material is going into each can. And is that range of variability within a set tolerance? And we can test that and we can measure that. And again, we're going to show you how that is to be done. And then moving beyond this course, thinking about measurements of data that are distributed through geographic space, we can produce maps that portray those statistical summaries and results. And there's a whole series of methods that are potentially dedicated to the spatial arrangement of data themselves. And those are things that then become sort of follow-on projects and options as you go through your degree. So when you think about statistics, and you think about quantitative analysis, and you think about math, which is actually arithmetic, which you've been doing since you were a little kid, sometimes it feels a little bit daunting to embark on something that you haven't been doing for a while. And you might see this big wall and you think, how am I going to get over this wall? My goal in this course is to take this wall and lower it to a point where you can look over that wall, you can step over that wall, and you can approach quantitative analysis, quantitative assessments with relative ease. This is my goal, and my understanding of the audience that always walks into this classroom at the beginning of the year, that there is some trepidation. My goal is to help you get through that. So that is roughly the space that we're going to be operating in. We've got data and we want to visualize it. We want to portray it in a way that makes it easy to interpret. But we also want to take different groups and compare them for their average values, the variability of those values. And to do that, we're going to come back to this idea of the new Kayama sign and thinking about the context by which we make measurements. And what I need to do is clarify 4 different types of measurements, this measurement framework that is going to allow us to figure out how do we count something and how do we measure something, and what is that going to allow us to do with the data. If you can understand these 4 different things, everything else is going to become much easier. So I want you to think about these and reflect on them after I finish showing them to you today. We're going to start off by talking about data in general. And we can split this, as we already know, into 2 different groups. We've got qualitative data and we have quantitative data. When we think about qualitative data up here on the top, we're talking about data, measurements, or observations that are categorized based on some kind of attribute or characteristic of that data, but it's not necessarily countable or measured in any sense. When we talk about quantitative data, we're talking about numeric data. We're talking about things that we can count, that we can organize, that we can measure and rank in some way. And these quantitative data split into 2 further subdivisions. We have discrete measurements and we have continuous measurements. Discrete measurements being those things that we can count, and we're going to see examples of these in just a moment. And the continuous measurements at the bottom are obtained by measurement. So this sets the stage for sort of all of the data analysis types of things that we can do. If we look at this bottom component, which are the quantitative data methods and quantitative data analyses approaches, these are things that we're going to cover in Geography 2420, Quantitative Methods. It's offered in the fall, and I will be your instructor. If you're interested in qualitative assessments, then you're going to sign up for ENVS 3010, and these qualitative methods are handled in a completely separate course because otherwise there's just way too many things to think about, and it helps organize our thinking into attributes and characteristics versus those things that are counted, organized, ranked, measured in the qualitative versus quantitative realms. So as I mentioned, there are 4 different levels of measurement that we're going to deal with in the quantitative realm. The first one here under my foot, whoops, over here, nominal measurements. And these are measurements that are simply named. Bring up a diagram here, a graphic. This baseball team, it looks like I'm part of the team, although my uniform doesn't match. So I guess I'm benched for the time being. But if we notice, on their jerseys, they've got numbers. And those numbers are nominal labels. Nowhere does it say that player number 9 is 3 times better than player number 3. It just simply means that player number 9 has a unique number, and that person is individual or different from player number 3. So the numbers on jerseys help us keep track of players, but the numbers don't have a meaning in terms of the position that they play, or how good they are, or how much they get paid. It's simply a nominal label. If we want to get into the next level of organizing our information, our data, we can move up to what's called the ordinal level, where we have these named categories, but we can also order them in a specific way where the order has meaning. You might be familiar with a classic podium, say from the skiing results at the Olympics, and we have 3 levels of platforms. The highest one for first place, a slightly lower one for second place, and a lower one yet for third place. And by the time they're handing out the gold, silver, and bronze medals, how quickly you ran the race course doesn't matter. It simply tells you that this is the order in which people finished, first, second, and third, and that's all that matters. So we know that position 1 is different than positions 2 and 3, and that 2 is different from 1 and 3, and so on. And we know that 1 was first, and 2 was second, and 3 was third. But the times or the scores don't matter, but the order is important. So we've gone from nominal labels to organizing those into a sequence or an order where that order has meaning. If we go from ordinal measurements to the next level, we have what are called intervals. And the intervals also have the ability to have named labels, and they're ordered, but the distance between measurements becomes really important. So imagine that we have these trees, and these trees are growing in a woodlot, and at some point we've decided that we're going to cut or harvest those trees. When we do so, we might label each tree or its remaining stump with a year. That year tells us when that tree was harvested. Now, not only does the label identify the trees, but the years between 2 successive dates tell us the duration between those harvests. So we now have the interval between these events that were happening also being recorded. So we could have these trees, each one of them has a unique number that is simply nominal, but we could also put them in numeric order that tells us what sequence they were harvested in. But with the years, we have that encoded into the data itself. So if we think about these trees and the harvesting, the order in which things happened and the interval between when they happened is all available to us because of the way that we decided to represent the data by years and not just by some random numbers that were assigned to the individual trees. When we go to the 4th and the highest level of measurement, then we have what's called the ratio scale. And here we have all the preceding sort of abilities of what our data allow, but we also have this idea of absolute zero. So if we go back to our trees here, the idea is that we have data where ratios make sense. So now instead of the year of harvest, let's put the age of the tree at the time that it was harvested, because we know that the absolute zero is year zero. This is when the tree was planted. It was 0 years old, and a tree that's 72 years old or 100 years old tells us exactly how long it's been since it was planted, but we can figure out what the relative aging between these trees are because we can take ratios. So as we go from nominal to ordinal to interval to ratio, we increase what it is that we're measuring. It allows us to do more with that data. But if we're collecting data and we are dealing with a budget of money or time, we may decide that we want to use a simpler scale of measurement because it's easier and quicker to acquire. And if we don't need the higher levels of measurement for the kinds of questions that we're asking, then it doesn't really matter. So how does this all relate to New Kayama? Well, New Kayama just assumes that all of the numbers that we have are ratio-based, that they're all measured the same way, that these values can be added or subtracted or multiplied or divided, but it obscures the fact that we don't know what the label is. So we need to know when we're collecting data or we're setting out to collect data or we're reading a question and we're trying to figure out what kind of data is provided to us, we need to think, is this nominal data? Is this ordinal data? Is it interval data? Or is it ratio data? It's going to allow us to understand what we can do with the data that we have. So plug this into your minds and you'll find that everything that you do from here on out will be much simpler. If we were to take these 4 measurement scales and we divide them down the middle so that nominal and ordinal on your left-hand side fit into sort of one family or one group, we have what are called the discrete measurements. These are counting and ordering things, but we're not actually measuring. And on the far right-hand side, we have interval and ratio, which are our continuous variables. These are the things that we measure. So you might use a time or a yardstick or a meter stick, or you're measuring something with a ruler or a scale or whatever it is. These are measurements that we can actually make with some measurement device, whereas the ones on the left are based on counting. So keeping in mind what it is that we're doing or what we need to do and how it fits into this structure allows us to figure out what we can do with this data afterwards. So here we have an example. We have a huge concert and there are lots of people at this concert, and we might ask ourselves, what is the average height of people at this concert? What is the average income of people at this concert? What is the variability in the age of people in or at this concert? And there are many types of questions like this that we might ask, and we want to depict that information in graphic form, or we may want to ask questions about that subset of people or that population. We might want to have different groups within the audience and compare whether or not some measurement value differs among those groups or not. We can start off by a relatively simple measurement framework. And this here is what's called a distribution or a normal distribution. It's something that you'll find sort of reoccurring quite regularly. We're not going to get into the details, but imagine across the bottom we have the height of people. And on the vertical axis here, it's slightly a little bit cut off here. It's the frequency, that is the count of how many times each of the people's heights happen. So I mean, at a concert, it's not a really great time to walk up to people and try to measure their height, but imagine we could. Imagine we could measure the height of every individual at this concert, and we then plotted sort of how frequently each of those heights occurred. In the middle here, where the purple arrow shows, is the average height of people. It's the one that happens to occur the most frequently. It's right in the middle between sort of the really short and the really tall people. This is a measure of central tendency, and we're going to look at different ways by which we can measure where's the middle in my set of data. Well, it looks as if you move away from the middle that the frequency decreases, and as you get to the far extents, you have very few really short and really tall people. This form or this structure is central to much of what we do in statistics. And we're going to come back to this sort of time and time again throughout the course, but you're going to see data relying on this distribution. The second thing that this diagram illustrates really nicely is the variability. Are all the people really tightly the same height as the average person, or are they quite spread out? So we can measure not only where is the central tendency, but how variable is that data. And those two pieces of information alone tell us a tremendous amount about any data set that we might be interested in. So when we think about measurements and we think about groups and comparing measurements among groups, we're often thinking about things like measures of central tendency. So here it's just kind of finding the balance point. And I mean, we're not going to be sticking potatoes and coins on a spoon and balancing them on the edge of our calculator. But the idea here is that there is some measure of balance where sort of there's an even number of people or things on one side of the average as on the other side. And how do we measure that and how do we characterize it? We're going to be looking at that. We're going to be measuring measures of variability. And you can imagine you're pouring coffee beans into this cup. Most of them are going to go into the cup, but some of them are going to, sprinkle outward, and you're going to have this spread outside of that cup. We now have variability. We'd like everything to be tightly in the cup, but things spread out around that measure of central tendency. How do you characterize that? How do you put that into quantitative form? How do you use that for making decisions? We're going to get into that. And we're also going to be looking at things, measures of position. So we have 3 snails here racing towards the finish line, and while their actual times might not be important, but who came first, who came second, who came third, that might be really important. And we're going to look at measures of position as well to try and figure out how do we describe our data and then use those measurements later when we're trying to make comparisons among various groups. So to get ready for the fall, I want you to be thinking about some basic things. I don't want you to be worrying about math. I don't want you to be worrying about stats and doing something that you haven't done in a long time, but remind yourself of basic arithmetic. Addition, subtraction, multiplication, division. Get those things figured out. If you haven't ever used Excel before, we're going to start from the bottom and we're going to work our way up and teach you all the skills. But if you want to spend some time with Excel and kind of getting sense of how does it work and what's there, by all means, a little bit of time invested in it now is going to make life a lot easier for you. I'm going to provide you with a few links later on at the end of this video that provide some really nice YouTube resources that can help you get going if you want to do some pre-study work for that. The third thing down here is the textbook. Many people say, I'm not going to buy my textbook. I'm going to save that money and I'm going to do something really exciting with it, like buy a drone, go to the pub, buy a tank of gas, whatever it is that you do. But let me tell you that the textbook is incredibly useful, particularly in this course. We tie what we do in the lectures and in the tutorials and the assignments very tightly to the textbook, and the textbook is amazing. It really goes through step by step of what to do from an applied perspective with lots and lots of examples to help you understand what you're doing. And finally, study skills, the sort of idea that you're going to have a midterm and a final and you're going to start studying 3 days before and get it all into your brain is the worst strategy that is known to humankind. And I would highly suggest that you think about studying techniques. I'm more than happy to share a few. I'm going to provide a link at the end of this video with a 1-hour investment in your time that is probably going to pay back 1,000-fold over the degree that you're taking at York University. Take a look at this video and really take to heart some of those studying skills. They're going to make your life a lot easier across all of your classes, not just stats. Take a look at those things, and we're going to see you in class in September. I look forward to meeting you. If you have any questions, my contact information is going to be on the closing slides. Happy to hear from you and answer any questions that you might have.